Okay, so in this video, I'm going to talk to you about testing, which is one of my favorite topics. We're going to look at two different types of tests, UI tests and unit tests. While we're creating our UI tests and our unit tests, we're going to take a look at a bunch of different tools that you can use in Android to create said tests. And I'll identify each of these tool sets as we go along. But before we jump into testing, let's take a quick look at this app that we're going to be testing. So it's a really simple app. It allows you to input some value. Let's try that again. Input some value, and then it'll calculate a tip amount. So, if you're trying to figure out what to tip your waiter at a restaurant, and if there's no value, it's smart enough to provide the user some feedback saying like, hey, you need to provide some information. So very, very straightforward. Now this app is created with two fairly simple Java classes. There is the tip profile class, which has two private fields, a simple constructor. Notice that the constructor has some invariant checking where it's going to check to make sure that the values passed to it aren't outside of some specific range. And then another constructor here that takes a context object. We're going to talk a little bit more about that in a little bit. One getter, and then has this method right here, get tip amount, which takes different inputs and then based on those inputs and the data stored within the class provides a different output. So we have a handful of things that we want to test here. Our main activity is pretty straightforward. So we have some items in our onCreate. We have an action, a settings bar that we actually don't really do anything with, but we could. We just don't. And then we have an onClick handler for our button that, of course, does that error checking that we saw earlier, where if you don't provide a value in for the costs of services, you'll get a toast that says, hey, check your inputs. And of course, we are inflating this activity using a layout file. So here's our layout file right here. And that layout file is pulling in a content file. And this content file is where we have all of our user interface defined. So we'll actually be coming back to this main content file from time to time as we're setting up our user interface test and our activity test. Our activity unit test, rather. So let's go ahead and start by creating our first test. We're going to start with the simplest test first, and that's going to be a unit test for trip profile. So what we're going to do, and I'll kind of expand this a little bit, is I'm going to come over here to these two folders, and these two folders which we've been ignoring entirely for most of this quarter. And I'm actually going to come to the test folder. Now this is where you're going to put your local tests. That is, these are the tests that are going to run purely on the Java virtual machine or on the Java virtual machine with some sort of fakes or mocking system to pretend to be the Android framework. So basically, this is going to run your code entirely on your development computer. It doesn't require a simulated or actual Android device to run. This Android test folder, this is for your, quote, instrumented tests. And those are the tests that do require an Android device to run on. So for our unit test for trip profile, we don't actually need to have an Android device running to test it. So we're going to put our our unit test for it here. Kind of as a rule of thumb, the instrumented tests can be more difficult to debug and can tend to be more flaky. So you probably want to create most of your tests as local tests as much as possible. Sometimes, and there are certain tasks that almost have to be instrumented. So UI tests, end-to-end UI tests really have to be instrumented because that way you get a real sense of what the user experience might be like. But for the most part, you might want to keep most of your stuff as local as much as possible. So, all right, let's go ahead and create a new test file. So we're going to create a new Java class. We're going to call it tip profile test. And I'm going to click OK. So now we're going to add our import statements, and we really just need a couple here. com.google.common.truth. And this we're going to use for matching for our test. And then import org.junit.test. Now we're going to actually create our tests. So when we do this, when you create a test, oftentimes you're going to need some code that will run before the tests in your test class run, and sometimes code that will run afterwards. So this is like common setup tasks, like creating a new instance of the class under test, or maybe setting up specific settings, or creating a specific state in the class under test. And so to do this, we're going to create at before, and this is an annotation that allows us to do some setup before the class runs, or the tests run. And in this case, we're going to create a tip profile called food service profile. And then before each of our tests run, and before I get too far, each of our tests is going to be a single method inside of our test class. So what we're going to do is we're going to create two methods that are going to run before each of our test methods, and then we're going to create a test method for each of the tests that we want to run. You'll see what that means as I go on. So at this at before annotation, so before each test, what we want to do is we want to run some setup code. And our setup code is going to be really simple. I'm just going to create a new instance of the tip profile class. So nothing too fancy here, right? So we want to create an instance of the class that we're going to test. Now, if we had some teardown code, so something we want to do after each test was run, we would create an after test, convention is usually call it teardown or something similar, but we don't really have anything that we're doing after our test, so I'm gonna leave that blank for now. So now we're actually going to create our test. So we're going to give it the @test annotation, and this brings us to the first of the tools that you'll become familiar with as you're doing Android testing, and that is JUnit. So JUnit is arguably the most common testing framework for Java, and a lot of the assert commands and matching, these annotations that you see me using right now, these are all from JUnit, right? So you see org.junit.after, .before, .test. JUnit is probably, if not always, going to be used in conjunction with each of the other three technologies or frameworks or tools that I'm going to show you in this video. So keep in mind that every time you create a test, you are almost invariably going to be using JUnit in some form or another. So, all right, first test. The first test we're going to create is going to be called public void. Test methods tend to be have really long names, and that's because you want them to be really descriptive. You want the test method name to clearly identify what it is you're testing and what's being tested. That makes it easier for you to debug the tests later on, particularly if you say have your tests running in an automated fashion. So you have a machine that just runs your tests over and over again, or runs tests automatically when you publish new code to GitHub. This might be done through what's called a continuous integration machine. So you want to give it a good, meaningful name so that if you need to debug it, you can figure it out. So let's do tip profile food server returns correct values. All right, pretty simple name. And you'll notice that as soon as we create this @test annotation and a method that connects to, this green run test button shows up right here in the gutter, which is kind of nice. So we're going to create a fairly basic test, and creating a test usually requires two sets of steps. So what you're going to do is you're going to go through the sequence of inputs for your class under test and get a value from that sequence of steps that you take. And then you're going to compare that quote actual value to an expected value. So in this case, we're going to do tip amount good equals food service profile dot get tip amount. And we're going to say 10. Let's go ahead and put this away for now. $10, and our tip amount is our tip type rather going to be tip profile dot service good. And then we're going to assert that, and that means check that or test that tip amount good. So this is going to be our actual amount, our actual value, dot is equal to, and then here's the value that we expect it to be, right? $2. And then we'll finish up our code here. Equals food service profile dot get tip amount. And it helps when you're writing tests to use simple values at first, particularly in tests where you're not doing a whole lot of fancy math. But if you are doing fancy math, then you definitely want to make sure that you vary your values. Particularly anytime where you have invariant checking, or you have different thresholds, or different behaviors based upon different ranges of values. But that's something that you need to be aware of when you're writing these tests. Typically speaking, the person who writes the unit tests for something should also be the person who wrote the code under test. That way they know what the class under test is supposed to do. Equal to mark 50, and then finally double tip pad equals get tip amount $10, tip profile dot service bad, assert that tip bad is equal to $1. So you've noticed that I've gone through the three basic scenarios that our tip profile might be asked to handle if we're doing tips for a food server, where the profile is like this. So you want to make sure that your tests capture as much of the variance that might occur in a specific scenario as possible. So this is one particular scenario. The particular scenario is I'm creating a food service profile for a food server, or a tip profile for a food server, and now I want to go through and check all the values. So now the next thing to do is we're going to run our test, and we're going to see if our test passes. So we're going to click this button, and we're going to say do that. And what's going to happen is you're going to see that the test window pops up, this run window, and it'll have a list of all the tests that we've run, which in this case is just one, and then it'll say whether they passed or failed. One other thing I want you to pay attention to is that up here, which the bar that shows which build configuration you're running, right? So normally we just run app, but you'll notice that now we have this tip profile test, tip profile, blah, 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 blah value. That's what's showing up in this bar. What does that mean? Well, what that means is that you can debug tests. So let me show you how to do that. So what you're going to do, we're going to set a breakpoint. Let's say we want to debug this test. We'd set a breakpoint. We'd click the debug, and boom, our checkpoint gets hit. And we can debug it, our test, just like any other code. So, and then we stop everything right here, like so. Pretty straightforward. So now what we're going to do is we're going to use what's called a mock for this next test we're going to create. So a mock is when you create a very, very thin facsimile of some code, some other code, in order to allow your test to perform correctly. The things that you might mock are like Android framework methods or services. So in this case, because we're running a local test, we aren't going to have access to the full Android framework. So anytime our code, our local unit test needs to access something from the Android framework, we need to figure out some sort of solution to give it the information that it needs without actually having some Android operating system floating around interacting with our test. So that's when the downside of these local unit tests is that you're not actually running against a full version of the Android framework. So that brings us to the second tool that we're going to look at today, and that is called Mockito. So you'll notice that one of the constructors for our trip profile takes an Android context object. And one of the things that we need to remember is that our context object is going to do a couple of things. One, it is going to provide access to 2 items contained in our resources. In this case, it's going to give us access to 2 strings that we've defined in our string resources. Now, the thing is that because we don't have a full version of the Android framework running, when we run our test and we create a new tip profile based on the context object, what's going to happen is that our test is going to bomb because it's like, I don't know what you're talking about. I can't find a context object. So what we're going to do with Mockito is we are going to create a mock version of the context object, of this context object, that is going to return a specific value when these methods are called. So let me show you what I mean by that. So what we're first going to do is we're going to create some new annotations. We're going to do mock, and yep, we want to add that. So you notice it adds our using statement, and we're going to create a mock context, and we're going to call it mock context because we want to make sure that when we're debugging our code later on that we know what it is that we're looking at. At mock. And actually, that's the only one I need for this one. That's right. Okay. So now what we're going to do is we're going to add some of this mocking code to our setup. So one of the first things that Mockito requires is that you have to call Mockito annotations.init mocks and then pass a reference to the current test class. That just tells Mockito, hey, there's this mock right here that I need you to be aware of. So Mockito also has its own nomenclature, its own built-in functions that you have to be aware of. And one of them is the when nomenclature. Let's go ahead and make sure we add it. So when mock context get string r string default tip profile then return default profile, and then when mock context get string r string default tip string amount, I think is what it was called. Yeah. Then return float. Oh wait, no. Is that right? No, we want to just return 0.25 like that. All right. So what this does is what we're saying is like we want you to create a mock context, a faked version of the context object. And this is going to be super thin. This mock context object is basically going to have no other implementation of context except that if you call getString and pass in this value, then our mock context object is going to return this. And if you call getString on our mock context object and you pass in this value, we'll return this result. So let's go ahead and see how that works in practice. Oh, and one last thing. Let's create our new, let's go ahead and create our new tip profile inside of a test. So let's do public void tip profile default profile. Just default. We'll call returns correct values. So in this case, what we're going to do is we're going to create a tip profile. Let's call it default profile. Default profile equals new tip profile. Then we're going to pass in our mock context object, right? Because this has got that built-in behavior that we've already faked out, or we've created fakes of up here. So hopefully when we run this, what will happen is that the test will call into our mock and get these values. Okay, so we're going to run one test here just for demonstration purposes. Double tip good equals default profile dot get tip amount $10 and tip profile service good. Then we're going to assert that tip good is equal to $2.50, and that's because the default value that we're default rate tip rate we're very generous that we're defining is a quarter. All right, so we've now created our test. We've got our mock. Let's go ahead and run it. And yay, there we go. And because we were able to mock this, this resource, our test was able to pull in our mock and get the values that it needed and run successfully. Okay. So we've now seen JUnit and we've seen Mockito. Now I'm going to go to the third of our awesome Android testing tools that we're going to discuss. And this one is called Robolectric. So if you want to think of different technologies for building your Android tests, you can bucket Robolectric along with Mockito. So Mockito is really, really good when you just have a handful of methods or services or classes that you need to mock in your test. However, if you need to mock a whole bunch of services, specifically if you have to mock a whole bunch of Android framework services, using Mockito can become really labor intensive really fast, because I mean, imagine having to write something like this for each of the methods of the context object, or an activity object, or the resources object, or so on and so forth, right? That would get pretty tiring pretty fast. So Robolectric allows you to use a relatively thin mocked version of the Android framework to provide values back to your tests. So rather than running all of your tests on an Android device, you're actually going to call into this fairly robust mocked version of the Android framework that will return real values, and it'll return real values based upon what's present in your app. So on your resources, it's actually kind of cool like that. And you don't have to write all of this mocking code. So here, let me show you what I mean. So again, this is another local test, so that we're going to add it to our local tests. We're going to do new Java class. We're going to go tip profile Robolectric test. And now there's a couple of things that you need to know about Robolectric before I get too much further. One is that it's still fairly experimental, and that means that it doesn't behave nearly as predictably as Mockito does. So if you run into problems creating a test with Robolectric, you might have to just suck it up and create Mockito tests. Mockito is much more predictable in how it behaves, but just requires a lot more code. The other thing is that in order to get this to work, you actually have to make some changes to your Gradle file. First Gradle change is this one right here. You're going to have to add this test options entry to your apps Gradle file. What this basically does is it gives Mockito, or Robolectric rather, the ability to actually include the Android resources in your file. That's which allows Robolectric to build the resources from your app into its own running operation. And then if that wasn't confusing enough, you also have to make a change to Gradle properties. You have to add this value: enable unit test binary resources true. This is another thing that allows your unit test to run against a compiled version of your resources. And when you do this, when you run your app with this setting, you're actually going to get a complaint from Android Studio, basically saying like, hey, this flag isn't supported and is experimental, and don't do that, and you're running with scissors. And like I said, if you want to use Robolectric, that's you kind of have to live with Android Studio yelling at you about that. Okay, so let's go ahead and create our first Robolectric class, test class. Come over here. So one of the first things you got to do is you actually have to use a run with annotation, and this tells the testing framework that, hey, this is the import class. There we go. That this is the specific. This actually tells Android Studio that when you run my test, this is the test running code I want you to run my test with. Yeah, so basically it's like use Roboelectric. I want you, when you run my test, use Roboelectric to run my tests. So now, one of the things that's kind of cool about Roboelectric is that you'll notice that the setup code for it is basically non-existent because I can do public void tip profile, default profile, returns correct values. What's required for me to create the mocked version of context is super simple, right? So I'm going to robo context equals. Now here's the magic. Here's the secret sauce for this. You're going to call application provider. And you'll notice that this is actually an Android x.test.core.app. There's some sort of relationship with Roboelectric and the Android x.test.core package. I'm not entirely certain what it is, except that I think that Android x.test.core is a sequence of hooks that allows Roboelectric to work with your tests. But regardless to say, application provider is the magic that allows Roboelectric to create a mocked version of the context for you. And then you're going to want to call application context. And that'll create a version of your context object. And then the rest of the code is almost exactly identical to what we wrote before. So let's come over here and just copy and paste this guy, and except we're going to call it robo context rather than mock context. So again, you'll notice that we're still using JUnit here. So we're using the JUnit assert that and is equal to. Let's go ahead and see if this will work. And it worked. Yay! Rejoicing in the land. All right. So we've now seen a couple of different ways to create a simple unit test of a basic data model class in Android Studio. So the next thing we're going to do is we're going to use Roboelectric to create a unit test for an activity. And so as you can see, like creating tests with Roboelectric is pretty straightforward. It's really quite easy. You can actually create a unit test for an activity using almost straight pure JUnit and Mockito if you need to get resources. But in this case, we're gonna see how quick and easy it is to do a unit test for an activity using Roboelectric. So let's create a new Java class. We'll call it main activity test, and hit OK. So again, we need to tell Android Studio that we want it to run our test with the Roboelectric testrunner.class. And then we're going to define our test. So test is going to be public void. And if you recall earlier, our code has the code of our app has a code path where if the data is empty, that edit text box is empty, what's going to do is it's going to show a toast. So one of the things that we have to do here when we write this test is obviously we need to create an instance of our activity class. We then need to click the button in the activity in this instance of our activity that's under test, and then we need to check that the activity, were it real, were to create a toast. And one of the things that's cool about Roboelectric is that it actually has a whole bunch of methods for checking that sort of behavior, and you'll see it in just a minute. So let's do test not enough data provided. And then we're going to create main activity. Activity equals Roboelectric dot setup activity. And then we're going to call main activity dot class. Really, it's that simple. And now that we create our activity, we're going to have to use some, I believe what are called matchers, but essentially we're going to have to use some code that allows us to isolate specific specific UI inside of our class and then perform actions on it. So in this case, we're going to do activity dot find view by ID, and we want r.id dot button is the name of our button. And then we're going to do perform, nope, that's not what I wanted, perform click, right? So find our button in our activity and then perform the click action. And so now we're going to write our assert. So we're going to say assert equals, and we need to import it. Let's do check your inputs. And here's one of these built-in classes in Roboelectric that's just so cool. Shadow Toast. It allows you to get gets access to a shadowed, mocked version of the toasts on side of your marked version of the framework. Shadow Toast dot get text of latest toast. And then, import assert dot equals. And now we're going to run it. Takes a little bit because it's actually going to create an instance of our activity, and hey, there we go. Success is ours.